Hello everyone. This lecture is the last one of this semester. So let's briefly review what we have learned so far. During this semester, at a high level, we have learned the essential techniques for building safe and reliable softwares. And as you can see, in the process of the traditional software development, domain expert manually found software bugs and manually fixed these bugs so far. And to replace this manual testing and the manual debuggings, we learned the two state-of-the-art techniques for software testing and automatic program repairs. So let's review the first technique, software testing. At a high level, software testing can be seen as automatic test case generation technique. So this technique takes either binary file or source code as input, and then this technique aims to automatically generate the test cases that increase code coverages and find many software bugs effectively. More specifically, from the first lecture to the third lectures, we have learned about symbolic executions, which is belong to white box testing method. And as we all know now, this technique is very powerful because it is able to systematically explore the diverse execution paths of the program by substituting the program input with symbolic variables. In particular, we focused on learning the modern symbolic execution, which is the dynamic symbolic executions. And also we learned the two main approaches of dynamic symbolic executions, which are conflict testing and execution generated testing as well. Furthermore, we investigated the open challenges of the symbolic execution, such as path explosion problem, and also learn the state-of-the-art techniques such as search heuristics for mitigating these challenges. From lecture 4 to lecture 5, we learned the white box testing method system specifically for testing deep neural network models. The key idea of the white box testing for DNN is to generate test cases by adding the gradient of the selected neurons to the original inputs. And compared to the traditional software testing, DNN testing technique takes as an input the DNN model under test, and it tries to achieve the following two goals. The first goal is to increase the coverage metric specialized for the DNN testing, such as neuron coverages or top K neuron coverages as well. And the second goal is to maximize the number of adversary inputs that make the DNN model foolish. And from the lecture 6 to 8, we have learned about gray box testing techniques that includes the some characteristics of the both black box and white box testing methods. And there are two main styles of gray box fuzzings, which are mutation-based fuzzing and generation-based fuzzings. The key difference between these two techniques lies in the how to generate the test case. Mutation-based fuzzing takes a valid set of input, and such as PDF and XML file, and generate the test case by slightly changing this valid input. In particular, we learned about the recent trend of the mutation-based fuzzing, which is program adaptive fuzzings. On the other hand, the generation-based fuzzing, which is grammar-based fuzzing, takes a grammar as an input and generate the test case by expanding from this given grammars. Lastly, we explore the automatic program repair techniques partially. They can be classified two APR techniques at a high level. Well, these are the general purpose program repair and the special purpose program repairs. First, the former technique, which is the general purpose program repair, aims to repair all type of any errors, but this technique may have poor performance for fixing specific types of the errors. And the latter techniques, which is special purpose problem repair, are specialized for fixing specific kinds of errors, while not generally applicable for fixing other types of the errors. In particular, in this lecture, we focused on introducing the state-of-the-art techniques such as memfix and saver for automatically fixing memory deallocation errors, which is one of the most prevalent error in the practice. Okay, let's finish this course, Advanced Topics in Software Engineering, with this review. You worked really hard to take this course during the whole semester, and I hope that you have learned or pick up the following techniques from these lectures. Okay, I look forward to seeing you offline next semesters. Okay, goodbye everyone.